Hi everyone. I actually not sure how many people seeing us right now. I'm just gonna throw a few sentences before give a mic to Igor, which he can also use himself, of course. Hi, I'm Alex, and this is Igor. We gonna do this stream together. I will be helping with hosting, and we have an expert guest who will be joining us time to time.
In a sec.
Occasionally. Yeah, feel free to leave any comments. Of course, we have a bit delay because it's a live stream, and I will throw these comments to Igor as soon as they come into play, and we have a moment to discuss. So today's topic: scraping Airbnb website with Python, Beautiful Soap, and Selenium. And with that, I give a word to Igor.
Thank you, Alex. Great. So I would start from a bit far. So let me share a presentation which we prepared for you. So I would like to start from telling some words about us, who we are, why do we do it, what is the motivation for us and maybe for you to join. And then I will talk a bit about the project, some overview, what is it about, what is the current plan. Then we will jump right to the code and we'll do some real coding. And then we will discuss the results. So hopefully it will be fun. Let's get started. So about us, we are Alex and Igor. I'm Igor, and Alex is also here. I could introduce myself, and then probably Alex will tell you who you are or who he is. I'm currently living in Vienna and working for a company, Crayon. I'm a data scientist here, and we are a consultancy, so we do multiple projects for different clients. So it's not like I do only one thing in data science, but from time to time we have really different tasks, from just analyzing some tabular data up to computer vision tasks. So it's kind of fun here. And if you want to follow me somewhere, please do it on Medium. I've recently started writing posts there, so see you there, hopefully. And yeah, I'm not sure if I should say something about me more.
Yeah, I love you occasionally in the stream, so that's fine. Hey, yeah, I see Andrew rejoined us, so I will also give him a word in a second. Yeah, hi, I'm Alex. I'm a good friend of Igor and hope Andrew as well. So we decided indeed to start this initiative this year. That basically is gonna be a set of meetups and also articles. Please follow us on Medium, on YouTube, any channels we're gonna promote during this session today. Yeah, about myself, I'm currently located in Amsterdam, Netherlands, and yeah, my background is mostly about programming. In fact, I started in 29, I think. It's been a long journey, and I usually say like, yeah, I started with JavaScript. That was my first language, which is can sound weirdly, but doesn't matter. So I started with JavaScript and. Recently changed my stack a bit to backend, so playing around with Golang and Java. And actually, our next event we're gonna announce is gonna be fully in Golang. So if you're interested in that, you're very welcome. I'm working in a company, ING, right now. It's a big European bank. Founded by Netherlands, and yeah, I'm doing some backend stuff there.
All kinds of stuff.
Right. Yeah, I will talk about that in 2 weeks. So please join our next session if you're interested. Yeah, if you're interested, I will be happy to answer anything in Twitter or also in any channels you can find me. And, with that, Andrew is our guest expert, and maybe you can say a few words about yourself, Andrew.
Hi, my name is Andrew. As you may know, I know those two guys, Alex and Igor. so far. And I actually started my career from C#.NET, and right after that I switched to PHP, which was the craziest switch in my life. Then I just, started exploring different languages, which was related to the things I wanted to do for myself, basically. So I started to do my own scraper of the web pages. So that's why I started to learn Node.js. And actually, Alex helped me with that very much. Thank you. After a while, I realized some disadvantages also from Node.js and other stacks languages. So I decided to try myself in Go language. And after a while, for now, I'm trying myself in some infrastructure stuff. So I mostly doing some stuff related to programming, but also touching Kubernetes, Docker, and everything related to that. How to scale this in the cloud, how to make it work and make it robust.
Sounds great. And thanks for actually underlining the why you've been invited today. I mean, because of your background with scripting sites, of course.
Yeah, I already have a couple of questions for Igor, but let's wait.
Let's wait, yeah. Do not throw them currently. So it seems like we have two serious software engineers and one data scientist. So by the way, I am not as a software engineer, let's say. I'm more like a script writer. So I'm a data scientist who comes from analytics, not from software development. It's a small disclaimer. Cool. So let's talk a bit about why do we do that, or why we decided to do this webinar and start our projects. So I was thinking about how to explain it, and I came up with 3 points. So for me, the first one is fun. So creating new projects and working with you and learning, it's really fun for me. I would like to be better than I'm today. I would like to create something meaningful, be it an example toy project or something production ready. It doesn't really matter for me currently. Second reason is learning and sharing. So of course, when we're doing that kind of stuff, we are learning ourselves, and also we share with you our findings and probably our way and our experience. And also a very important point is people. So when you start doing some activity, you meet people, you talk to people, you have discussions with them, and that is the best part probably of the whole community. That is why we do it. And actually, I suppose that is not only for us. I hope that some of the points are valid for you. So why did you join this stream? Probably because you want to have fun, meet people, and learn and share. Cool. So then we could jump closer to the project. I think it was around December when we started these discussions with Alex about what should we do. And I was thinking, what kind of project could I start and could I run? And for me, as I'm a data scientist, it of course should be about data science. And I was thinking, what type of the project could it be? So I'm usually not a fan of some rocket science. So when I go to some conferences, I usually skip the tracks where people talk about new machine learning methods, new research on the edge of our knowledge, or something which is purely theoretical. I usually skip these tracks, and I usually am more interested in some applications. So if there will be a talk which tells us how to increase the time spent on the website by 5%, I will be really interested in that. I will go there and listen to how people do it. Because most definitely they do not use some really advanced stuff, but they made it work. And that's what's of great interest for me. So that's why I decided to do some not really complex project, but the one which is about real stuff. It's not theoretical, it's about practice. And so I have to decide the domain for this, and this is about my interests. One of the great interests of mine is traveling. Mostly I dream about traveling. I'm not doing so much traveling as I would like to do, but when I do it, I usually plan it quite comprehensively. I go to different web forums, I read reviews, I'm trying to find points of interest. I'm looking at different maps in order to create logistics, how to travel from one point to another. And in the end, I book something. So I book accommodations, I book flights, car rentals, you name it. So thinking about it, I decided that doing something in travel domain would be nice. And to do some data science project, we have to have the data. That is point number one. And usually in real life, the data is not just lying around. So you have to create your data set. You have to, if we're talking about some industry company, you have to talk to people. They will tell you where is the database which has the data. You should go there, connect, understand what's inside, browse it, then write some scripts, and only then you have the data. I tried to mock it as much as I could. So we will also make some actions in order to obtain the data, and that will be our step number one. We will go to Airbnb website and we will scrape some data from there. Then when we have the data, or when we would have the data, we will have to process it and to clean it, because what we will scrape today from Airbnb website will probably be not very clean and not neat. And in order to use it in further stages, we will have to do some pre-processing. That is a step number two. Hopefully it won't be such a problem. And we will smoothly go to step number three, which is about some modeling. So usually when we're talking about the data science project, it's the most fun part as people think about it. So it's building the model. And here I thought, what kind of model could we build? And I came up with something really simple. I think that we would be able to predict some price of the accommodation on Airbnb. So I'm not sure how familiar you are with machine learning models, but just like in a few words, what does it do? So we will build a regression model, and regression model tries to predict some value. So this value will be the price of the listing. So every listing on Airbnb has its price and also has its different properties, its other features. For example, location, the name, if there's a Wi-Fi, the average review of this host, and something else. And this we consider as features. And based on these features, we will predict the final price of the accommodation. So this is step number three, and I think that will be the most challenging step, because I'm completely not sure if this model will show some appropriate results, but we will see. We're still not there. Let's do it step by step. I actually see that I'm kind of alone here, but hopefully it's not a problem. Yes, Alex is back. Great. So after we build this model, it will be nice to somehow use it and to build a tool around it, because the model is some Python object which you could run in your Python script, and you could explore it, do some data analysis, but it would be nice to use it in, let's say, a real world. And what I thought about is creating some Chrome extension. And this extension will be activated when you're on Airbnb website. You will go to the website, browse for your accommodations, and this extension will advise you if this price is good or not. So basically, is it overpriced or underpriced? So this is the current idea, how I see the project, which I called Airbnb Analytics. So I think it's enough for the introduction, and now we could go directly to the code. And by the way, I will be pretty happy if someone will ask questions in the chat. And actually, it's also valid for Alex and Andrew. If you would like to ask me something, I will be happy to answer you.
Yeah, indeed. So far, now that if any appear, I will just interrupt you and throw it.
Great. I like to be interrupted, so that you know. Great. So this is the Google Colab. I'm not sure how much of you are familiar with that. It's basically the Google service, which is built around Jupyter Notebooks. And Jupyter Notebooks is some tool which allows you to run code interactively. So I mostly use Python, but I think you can run different languages in there. And interactively means that you run some code, and then all the variables are in your environment, and you can reuse them afterwards. That's what I really like to do, because I'm an analyst, not a software engineer. So let's start. At first, we will look at some different page, not Airbnb page, and we will see how we could extract some data from this page. There is a very nice library in Python. It's called requests, and it has the basic functionality for extracting HTML code from websites. I tried to pick a toy example here. I really wanted to find a very lightweight website so that it doesn't have a lot of HTML code. And I stopped at this light version of CNN.com. So let's just take a look how it looks like. I really like Jupyter Notebooks. As I said, you could render the page right here. Let's do it. The way everything works so far, it's just amazing. So this is a very simple page. You have the header which holds the date, and you have the list of stories of the news, which are probably very important today. You can scroll. But basically, it's very simple. So you have a lot of different links and the headers for these links. So let's use requests library and extract the data from there. So for that, we use the method get. It gets the HTML from this URL and puts it to the answer object. And the answer has a couple of methods. I will just show a couple of them. So it says that the URL is the following, and also it tells us that the status cost is 200. Means that everything went well, and we got our HTML source content. And now we can take a look at this content. I will print it, but it's actually quite huge. Here it's rendered as a line. I will try to scroll a bit. It's like a lot of different symbols, very hard to follow. So probably we need something else in order to navigate in it. And that's great. We have that kind of tool. In Python, there is a great library, Beautiful Soup. And that is how you import it. Afterwards, you can say, hey, Beautiful Soup, read this page, which we already downloaded, and it's an HTML, so parse it, please. Now we have an object which is called soup, and there is a nice method, prettify, which tries to make the content quite pretty, and so let's print it. Now it is a bit more readable, let's say. We see that the website consists of multiple objects of the same structure, so it's a list, and every list element represents a link which has a URL within, and also the title. Now what could we do with that soup object? It also has some methods. For example, we can get the title of the page. It tells us CNN breaking news, latest news. And so what we will need afterwards is, of course, extracting some elements from this soup variable. So Beautiful Soup tries to represent the HTML content as some kind of a tree. And you can navigate through this tree and grab the elements which you are interested in. So here we tell Beautiful Soup, hey, find all elements of type A and show to us the first 10 of them. So let's do that. Nicely, it extracted the first 10 elements, which are links, and here they are. And we basically have the source code of them. If you would like to have access to the text, there is a pretty easy function, a method, get text. So we find all the objects which are links, we get one of them, which is number 5, and we apply get text method. And nicely it showed us the title of the 5th link, and yes, it's Novavax vaccine. It's about COVID, yeah. It's effective in trial. Well, that's pretty nice because I don't usually follow the news. And now I can at least read something. Great, so this is kind of some introduction. So how can we scrape the pages? Now let's get to our Airbnb. Let's scrape Airbnb. I think we could start from opening it on our website. Let's try type Airbnb. But here, that's how it looks like. And what the customer usually does, we go and search a location. By the way, I was always experimenting with Marhofen. That's a very nice ski resort in the Austrian Alps. I think Andrew was there for a couple of times, and that's one of his favorite places to go.
Yay!
Yay!
The best place.
That's the place. Yeah, probably you know it by heart because you've been there, I don't know how many times. So I was there only 2 times, I suppose, but it's really great. So yeah, let's pick the dates when we want to travel, and we want to live in a nice cottage or house, and let's pick 4 adults because we're cool. And no, I don't want to log in. No, I don't want to log in. Yeah, let's type search. And that is basically the page that we would like to scrape. It shows us 300 plus stays in Marhofen. We can scroll through them. We can also see them in the map. But basically, we are now interested in this URL. I will copy this URL and go back to the script. And we will call it Airbnb URL. Copy paste, it's my favorite action. So now we have this URL in memory, and we can parse the website on this URL with beautiful soup as we did before. So let's just rerun the functions. It takes a bit more time. So hopefully now in this SOAP object, we have the content of this page. It would be nice if it works. So let's print it. And it should be really humongous. So I don't even see the scroller. It should be somewhere on the right, but let's find something. Yeah, Airbnb. So basically it should be an Airbnb web page. So hopefully we're good. But it's huge, so I will just delete this output because it's too big. Now, no, I'm jumping a bit too forward. So we have this object, and now we would like to find something meaningful there. And what is meaningful for us? So for us, meaningful will be the price, of course, the review, the average mark or grade for this customer, the amount of reviews, the name, the rooms, basically everything you could see on this small listing icon, however you can call it. And now we have to somehow access all these elements. The easiest way to do that is to use the Chrome developer tool. If you press F12 in Chrome, you will, no, that was not correct. Again, I'm working with the laptop. That's very nice, yeah. So if you press F12, you will see this developer tool on the right. And you can basically navigate through you can hover on different elements on the website, and this developer tool will show you what is exactly in the code. So there's a nice button, search and select an element and to inspect it. I press it, and then I just hover here. And if I click, it shows me, hey, this is that element. So let's just find the element with the one listing. And you can take this one. So if I hover here, it says on the left, you see that this is one listing. If I go a bit higher, so this is all the listings. We actually need only one, so I will copy this class and go back to the code. Yeah, we can put it here. It's already here, actually. And let's find all the elements within this SOAP object, which are divs. So the type of the tag is div, and they have the class with this fancy name, which I can read as giggle, but it's not giggle. Great, so we find hopefully 20 elements, because usually an Airbnb page has 20 listings on one pagination. And we see, if we scroll right, we see a lot of stuff here. Actually, I think we can even try to scrape a bit less, because we scraped too many elements. I think we can go a bit further and, yeah, take the smallest rectangle, let's say. So because we took this one, and now we can take this. And this is the another class. Let's copy it. And run this one. So basically, we also have 20 elements, but now they are a bit more clean. So we see the name right away. And yeah, now let's just put it to the variable so that we save it and explore the first element, only the listing number 1. What we could do here. So for example, we can find the link, because we are pretty sure that there is a link. If you hover on the listing on Airbnb website, you see that you can click on it. Actually, we will do it. You will go to the detail page of that listing. It takes 6 seconds to load. A very nice listing. So basically, there is this link. It's hidden somewhere in the element, which we just extracted. And to find it, we apply our method find all. So we're looking for A, which is the tag for a link. And we want to get the first element and extract the link itself. And the URL itself is stored in the href element. Actually, we can see it here. So this is the element A. And if we scroll a bit to the right, we see this href. And it holds the URL. So let's do that. Amazing. It works so far. So that's how we could extract the link. And what else could we do? We could extract all the text which this listing holds. And we can just run this get text. And here we get everything which is a text and which is within these elements. Basically, it's what we want, but we would like to do it in a cleaner way, so that we won't have to do a lot of processing afterwards. It's better to scrape elements one by one. And for that, we will jump further. That is actually the image from the article, which you could find on my Medium account. It's medium.com. And here I try to mark all the elements which we are interested in scraping. So there is a header, there is a name, there are rooms. Sometimes Airbnb puts the badge. Here it says a rare find. No one knows what it means. Probably Airbnb doesn't as well. Also another page, superhost, ratings, URL, and the price. So now we will have to think how to extract every single one of them. I picked here only 3, for example. I inspected the page and put here the tag of every of these elements. So for URL, we already know it. It's stored in the tag A and sub-element href. Name is stored in the tag div with this class. And the text itself is stored within sub-element area label. And the same about the header. It's also in the tag div and with different class. So now let's write the function which will scrape all the data. And now it says first generation because that starts with something easy. We will just manually iterate through all the elements which we are interested in, scrape them, and save them into some dictionary. So basically, we repeat everything which was written here, but with Python code. We take the input argument, which is the SOAP of the web page. We find the corresponding element. Sometimes it has the class, sometimes it doesn't have the class, and then we extract either a specific sub-element, like here, or we just extract the text, which is within this element. Then we put it to the dictionary, which we created beforehand, and we output the dictionary as a returning object. So let's run this function on the listing number 1 and number 0. And we scraped actually the first listing. Now we have its header, we have its name, and we have its URL. That's really great.
Heyo.
Yep. Hopefully I'm not alone here.
No, it's going very well so far. I actually wanted to maybe give you some pause, and yeah, I don't see any much comments in YouTube, unfortunately, but yeah, that's also fine. But maybe we can discuss a few questions right now. I actually also turn on Andrew. So for myself, I actually haven't done Scrapper myself ever, but I've been working on some related task in a while ago. Basically, it's about CSS selectors. That's one of my favorite questions for the JavaScript interviews, by the way. Like how you gonna build yeah, the question is like how you can build a unique selector for an element or on a page. So if you can scroll up a bit your code now. I actually had a thought in here. Well, of course, these selectors, they sound like automatically generated. I mean, classes, and yeah, you using classes only so far, I see. So my thought was like, would it be an idea actually to pre-configure these selectors a bit? Like if you don't put it into the code directly, but you have like some kind of list of elements that you want to scrap, and then you just use them in programmatically, you know, like from some hash map where you just go in through the selectors that have some meaning, semantic meaning maybe. So don't just do it manually for every piece of page that you want to scrap. That was just my thought on what I saw recently.
Yeah.
Yeah. What do you think?
That's a pretty valid thought, and if I understood you correctly, I probably will do something which you're talking about. So it will make our life a bit easier. But also, yet a valid point that these classes, which we see here, they are pretty random or arbitrary.
Yeah.
And Airbnb could change them anytime.
Yeah, exactly. Yeah, I think we've been discussing that on one of the sessions together, right? It might be that they just release a new version every week, and these classes will be generated every time. Yeah, so that very unfortunate.
That would be the worst case, actually. Or fortunately, it's not the case because I've checked this. I'm already checking it for quite a couple of weeks, and at least they do not change these tags.
I would say even more. As for my previous experience with web scraping, even one website can release like 3 different UIs, and in this moment only some of your scrapers will work. So that's kind of a thing you need to investigate on, like when you're scraping a lot of data and just analyzing how it goes. So it could be different. It could break in any time, basically.
Yeah, that's also completely correct. There are probably some A/B tests running, and you can suddenly find yourself in the page which you were not expecting, which has different elements, different classes, and whatever. I tried to think about it a bit. Of course, I didn't solve all these problems because they are maybe not really solvable, but I tried to do something. So
another thought I had actually is about, like probably CSS selectors is easiest to simplest to use for scraping. But have you ever heard about XPath? Sorry, have you heard about this technology as well?
I think I heard about it. That's all I could say. So if you
in short, it's an alternative for CSS selector. So I was wondering if actually these libraries can support something like that, and if that could be, I don't know, a better way. But basically they are doing the same, just specifying a path to an element to a page. So I was just wondering how popular it is with Python to use the XPath or something like that.
I don't know. Maybe it is. Maybe it is, but it doesn't solve the problem of different names of the classes, right?
No, it doesn't. No, that's correct. Okay, I don't see questions in the chat so far. So let's continue. If maybe Andrew has something to add.
Yeah, let's see. So far he has a coffee. So yeah. So the next thought, I think we talked a bit about it. So what if the tag we're trying to scrape is not on the page? So for example, we're trying to find the tag B, and let's just do it. Of course, we have the error, and we do not want our script to suddenly break in the middle. That's why we somehow have to handle this error. Again, the second generation is the easiest solution for that type of problem. In Python, we have a very nice way to do that. We can do try except. So we basically try to run the function. If it runs, then good. We have the object stored in URL. If it fails, then we go to except, and we just tell that URL is empty. That is just nice manual handling of mistakes, of errors. So basically no other differences between the first function and this function. The only thing is we added try except. So let's run it. And yeah, so we try to scrape here the tag B. And as there should not be a tag B, our URL should be empty. And we see here that URL is empty. So at least our function didn't break. That's great. Then we would like to think about a bit more about the function. Now we are scraping only 3 elements, but even for the basic web page, I will scroll a bit back. So we see here, I think it's 1, 2, 3, 4, 5, 6, 7, at least 7 or maybe 8 elements which we would like to scrape. And of course, we could write 8 different rows, 1 per element we would like to scrape. But I thought of some kind of generalization of the function. That's why we created this dictionary. I call it rules for the page. And here we specify all the things we would like to scrape. And in the dictionary, we have the kind of the path for the corresponding element. So the badge is stored in the div with its class and so on. So we have to rewrite the function so in a way that it understands that kind of dictionary. That is our third generation. Again, its argument is the soup element, which stores the content of the HTML, and now we also give it this dictionary parameters. And there are 3 steps. First, we try to find the corresponding tag in the listing. If it's only the tag, for example, if you would like to scrape the URL, there is no specific class for URL. We just do find all and parent tag. Sometimes we have to specify the class. That's why we run this function find all with 2 parameters. Now we have these elements found, which should hopefully store everything we're interested in. And now we might be interested not in all the elements of the type, but in a particular one of them. So for example, here we see that the rooms and facilities are stored in the exact same element, div with this same class, but the rooms are stored in the first element of zeros, and the facilities are in the next one, which is the first one. That's why I introduced this parameter order, which tells us which exact element we have to extract. So here we specify it, we extract the one we want. And next we would like to get the text, not the whole tag. Here again, it's either we specify the exact tag, like we did before with href, or we just scrape the text if there is no specific tag. So basically these three steps are generalizing the function, and now we could run it with two features. So we will extract from the first listing only the features header and URL. And now it doesn't work because I forgot to run this cell. Nice. So we have the header and we have the URL. Next thing that we have to do is just to iterate through all the features we would like to extract and do that. So we'll just print the results. And now it doesn't work again, because sometimes some of the features are not just present on the web page. So if we go back to Airbnb website, I will scroll. Yeah, so for example, this listing, we have this title superhost, but in the listing above it, we do not have it. So this tag is just not on the page. How to solve it? Again, the easiest way is to apply our favorite method, try except. So when we iterate through the set of features, we tell Python, so try to extract it. If it's okay, then print. If it's not okay, then print that the feature is empty. So let's do this. And that is output, our output. So it has 9 features and 2 of them are empty. So this exact listing doesn't have the badge and it doesn't have the superhost badge again. So actually, that might be the end of our session. We extracted all the features from one listing. And as we can do it for one listing, we could do it for the whole page. Yay. So Alex, if you would like to say something, please do.
Yeah, I thought it would be another hour, actually. I was looking at the numbers of seals covered. Okay, good. We're right in time. Yeah.
I mean, we can extend it a bit more, and actually we will.
Yeah, sure. Maybe we'll have some a bit discussion. Maybe Andrew has some comments, and yeah, feel free to also for everyone who can see us on YouTube to ask your questions there. We see them. Yeah, I actually have some pre-prepared questions from my buddy. So who is?
And actually, by the way, I'm just telling that it's not the kind of end of the.
Yeah. So right. Yeah. So which package have you been using for? It was Selenium, and before that it was some other stuff that you showed, right? Was
so for now we didn't use Selenium. We used only Beautiful Soup, which helps us navigate through the page, and we used requests package, which gets the content of the page.
Okay.
Basically 2 packages only.
So I've been told that there is a Scrapy package. I don't know if you heard about that.
There is.
So why not to use Scrapy? What's bad with that?
Honestly, I don't have the specific answer for that. One can use almost any package which is there. I think I haven't ever tried Scrapy, but I know that the company which does it is very successful, and this package is quite famous. So I suppose it's very nice and one can use it, but just I turned out to use Beautiful Soup and request for that. So.
Okay, I thought it's kind of system package. Okay, then makes sense. Just a utility that fits it. Okay, fits in. All right. Actually, I'm not sure if I saw that in the code or not. Maybe it was the other part that will be probably shown next time. But waiting and clicking scenario, was it? It's postponed, right? It's for the next time.
Yeah, it's where I decided not to put it here because it's a bit too much.
Yeah.
That's where we would have to use Selenium.
Yeah. Okay. And actually, for the previous question that I asked, I think I saw it already in the code that you created this dictionary with the URLs and not URLs with the passes constructed. So yeah, that was my question about.
Yeah.
Okay, Andrew.
I thought a bit in advance.
Yeah. Andrew, how is it? How does it look?
How's your coffee?
It's good. I'm still in Moscow.
Well.
So as far as I understood, so for now you just showed us on the scraping stuff, and all the data science stuff will be shown the next time, right?
Yeah, completely correct. So now we're just getting the data, and then we will process it and jump to data science.
Yeah, I had a little bit experience with how to call it, Python book or something like that.
IPython. Oh, Jupyter, right?
Yeah, no,
Jupyter. Jupyter Notebook.
It's IPython, yeah, Jupyter.
Yeah, I've tried it a couple of times, and basically it's good when you do a presentation, but then you need to actually export somehow the code from there and actually run this code on the server to get the solution scalable and even extract a bit more than one page. So did you have some understanding how to do this using Jupyter? And
well, yeah, your point is totally correct and valid. It's probably not a good idea to use Jupyter when you're doing real scraping afterwards. So for now, we're using Jupyter only to do the presentation or to explore our variables in an interactive way. But afterwards, of course, you can wrap it into a Python file and create some service and Python script there.
Yeah, I think Jupyter Notebook even has special methods to just extract all the Python code as a simple Python file.
Yeah,
so
I think it's as easy as this, which will work somehow. Of course, you have to clean it afterwards because you will have all the outputs, or maybe not the outputs actually, all the comments. But
regarding scraping, I've heard Alex said that you may need to click somewhere to extract something. Is that your case?
Yeah, it's our case because some of the pages, actually detailed pages, are dynamic pages. So you have, first of all, you have to wait a bit before scraping, and then there is some information which we're interested, which is hidden behind the button. So to look at the entities, we have to click on it, and that is where we will have to click. But we decided to leave it.
Have you been trying to research? So if you refresh this page and go to the HTML code, will you find in the text these values somehow, which will be shown when you click, or it's delivered dynamically when you click?
It's delivered dynamically, yeah. So if I would like to look into the HTML, I won't find it only after the click.
Okay, I see. And so in this case, Python won't work for you, right? To click.
To Python, I won't say that Python won't work for me, but requests library won't work for me, yes. Exactly, because it extracts only the HTML base code. And that is where we have to use Selenium, for example, or probably Scrape as well. So Selenium will allow us to go to the page and to wait a bit for all the elements to be loaded, and then also to do the clicks, and only afterwards extract the content of the HTML to our beautiful soup.
So I can share my experience, what I used. I don't know how to send the link, private chat. Anyway,
I think you can post it to YouTube.
Oh yeah, actually, does that. Oh yeah, I see.
Yeah. So this is a Puppeteer. It's been developed by Google guys who is really, enjoyed Node.js, and it works based on Chromium, which is like a headless Chrome version. And basically this stuff allows you to do whatever you ever need on the page, like click, wait. I use that to do global extracting. Another thing which you may need to think in the future, why probably you need to use this instead of Python, as it allows you to dynamically add different proxies. As I think if you will try to extract like 1 million pages from Airbnb, they won't be happy very much, and they will try to stop you of doing that.
Yeah, you're right.
In most cases, proxies helps when you have a smart rotation between them. So Airbnb won't really understand that it's the same code.
Yeah. So that's how we could cheat on them.
You could try to, yeah, but another thing like captchas they can show you. And in this case, it's gonna be much harder. There is also some services which allows you like dynamic resolving captcha solution.
Yeah, well,
but that's gonna be very expensive for you for sure, because if they start presenting captchas, it's gonna be like on every request, and you have to pay even cents. But when you extract 1 million pages or 10 million pages, it will be very expensive.
Yeah. So, well, basically, they want their website to be scraped, and we want it to be scraped, so we have to step into this battle and
So Igor, I guess the question actually is a valid one. Like, how did you choose Python? Why not Node.js? I mean, indeed, it's Puppeteer. I think we briefly talked about that before. Like, why to use Node.js or not to use Node.js? Or maybe Andrew, you also have experience of choosing between these technologies while scraping a website.
Well, for me, the answer is pretty simple. I don't know JavaScript. I know Python.
Yeah.
So that's why for me it's not a question. I'm doing all my data science in Python.
I actually have also a good, well, not benefit, but like, why would you like to use it in a project like that? Is because I'm a big fan of like keeping things simple, and in this case, simplicity for me would mean that you have the all tech stack on your project in one language. If that can be achieved without much effort, then I would say that's could be a good decision.
Yeah, I also think the same. So probably if we think about the production system, which has to scrape millions of Airbnb web pages every, I don't know, second or hour, then maybe we will use some different language. But for me now, it's much easier to work with Python, and all the projects could be done in Python, and there are a lot of libraries which allow us to do that. So for me, it's an easy way, the easiest solution.
Yeah, I think any project can be done on any language. It's just, you know.
It's just I don't know all the languages.
Yeah, you have to pay just different amount of your time for that on different languages to achieve the same.
Yeah.
I have a question regarding maybe overall to the project. Can you briefly explain what is the final goal of this analytics? What exactly you are trying to analyze, and what will be the benefit, the output, where the profit is?
The profit is nice question. Yeah. So I wanted to create something which looks like a real data science project. Of course, it is not real. It's like a toy example, but I wanted it to be as much similar to a real one as I could do it. So that's why I wanted to not to get the data, not to download the data from somewhere, but to obtain it. So that's the scraping part. Then I wanted to do some modeling part, which will be in the next sessions. We will try to predict the price of the listing based on the features of the listing. And then how to apply it. So I thought of some applications, and I just came up with an easiest one. We could create some extension for Chrome, and when you go to the Airbnb webpage, you scroll through the listings, and this extension will advise you, will tell you actually whether the specific listing is worth booking or not. So in terms of price, so is it overpriced or underpriced? So that is my idea currently. Of course, it might change during the project. Yeah, we'll see.
I can tell you about my pain when I usually visit such websites like Airbnb and Booking. I have 2 kids, so for me it's very important to find the best location of particular apartment which I'm going to book. And recently, when I was booking summer vacation, I was looking comparison of the beaches which is nearby, and how far is it, how good is it, what is the quality of the beach. And there are a couple of websites which actually gives you this information about European beaches. So you can get this, but you have to manually in your mind compare these locations to the this beach information. Is it sandy or not, and so on. That was very challenging for me, and I was thinking maybe it would be a good idea to extend this information on the Airbnb. And I even think that you could sell this information to them somehow.
Yeah, if I have this information. Yeah, no, that's actually a nice idea, because I also have that kind of problems when I'm planning my trips. I also would like to know what kind of the beach is there, because sometimes you see on the map that it's kind of a beach, but when you turn to the Earth view, or how it's called on Google Maps, you see that there is no beach actually. It's just the seaside. You can only walk there but not swim, and that completely changes the whole planning. So that will be really nice. But actually, I think Airbnb has, among some of the features, it has something about like the distance to the closest beach, the distance to the closest object, and so on. So you can actually extract it. And that could be another application, because we can not only tell you if the price is worth it, underpriced or overpriced, but we could also create some filter. So you could just simply tell, I want Wi-Fi, I want not more than 1 kilometer to the beach, and it will filter it for you. Because
actually the website which I was looking during this research, they show you not only information about the distance but also about the quality of the beach. Is it okay for kids? Is it, and like kind of 10 different values you get from there. So this is also very useful to apply filters.
Yeah, totally. Great. So I think I can probably jump back and
exactly. That's what I wanted to propose. Let's try to keep timing, and let's maybe wrap it up. And if we have still some questions, of course, we're gonna answer them.
Yeah, so it's not that much left. I think the only thing which is left and which we didn't talk about is some pagination, because Airbnb website has 300 plus stays for Meerhofen, and on this page we see only 20 of them. And if we scroll to the bottom of the page, we see that there are 15 pages. We can jump in between them, and actually we'll have to scrape all of them. So we can do it in many different ways. We could click on the button and get the new web page, but I think the easiest is just to see how the URL is changing when you click on the next page. And that's what I actually did before. So we see that if you're on the page 1, you have that kind of URL. If you click on the next page, there is just a simple parameter, items offset, added to the URL, and it's equal to 20. On the next page, it's 40, and so on. So we can very easily mock it. So that is our initial URL, which does not have anything in the end. I mean, items offset. It's the page number 1. And let's just finally write this function which extracts the listings, because before we were not using the function. And yeah, let's extract listings, check if it's working. We have 20 listings for the first page. And let's just try to apply this simple logic to the initial URL. We just concatenate this thing, items of set equals 20, and we extract the new URL. That's super simple check. Also, we have 20 listings on the page, but just to be sure that we didn't scrape the same page, let's extract the name from our new URL and also from the old one. So hopefully they are different. I really do hope. Yeah, so they're different. That means that we kind of extracted different pages. And now we could collect all these links of different paginations that we have to extract with from Meyerhofen. For that, we just iterate through all 15 pages. We manually create this offset, which every time changes by 20. So we just concatenate it to the initial URL. We scrape this new URL, and we just add these scraped listings to our object all listings, which we created before. And I wanted to check how it's working. And here I'm outputting the number of total listings which we scraped, just to see how does it go. So let's run it and see. So for now it goes okay, but I'm pretty sure that it will stuck at some moment. Yeah, so now we see that it didn't scrape all 20 of them. 2 were missed. Here it didn't scrape anything at all. And now it's stuck. So there might be some different reasons for that. I think we talked about some possible of them. So probably Airbnb tries to prevent the scraping. So it doesn't like that we're sending too many requests with the same user agent and IP. So the very easy way to do, which I tried, is to wait a couple of seconds after a request. Let's try that. So we have this library time, which we import, and we just add the sleep of 2 seconds after every iteration. Let's just see if it changes something. Hopefully we will be able to scrape a bit more than before, but maybe we are not that successful. So far so good. The last time it actually broke on 158. So hopefully this time it goes a bit further. And yes, it did go a bit further. 2 more pages. Yeah, now it's stuck again. So this stupid method works a bit, but of course it's not perfect. And
it's been executed on Google servers, right, with this tooling?
Sorry, can you say that again?
It's been executed in some Google cloud.
Yeah, exactly. So we could manually change the user agent for requests library, and we can try to do it random every request. That might be another way, but our IP, I suppose, will be always the same. So we have to do one of the things which Andrew proposed before to get more serious.
So any hard limitations on this tooling if we want to scrap some big resource of data?
You mean with that exact script, or
with well, how that's called?
Beautiful request?
No. Research Google.com, this Colab website.
You mean? I mean, you have only like the computational power, which is limited to the CPUs, and the memory, which is limited. I'm not sure.
Okay, but it's free except that this limit. Okay.
Yeah, it's free. Just if it's stale for 15 minutes, I think it stops the runtime, and you have to recreate it. I think it couldn't just kick you out with no reason, but you never know. Cool. So yeah, it's some improvement, but not perfect, and we have to think more seriously. And here I'm just checking if we downloaded something valuable. I took the random listing, which is 113, and let's look at its name. And at least it had some name, which is some different. So now we have everything we need to scrape the listings from all the search pages. So basically 2 steps. First, we build all the URLs from different paginations, and then we iteratively scrape them. So here we just create the function. Here we build the all URLs. This is the save function to extract all the features, which utilizes try except construction. And this is the scraping of the search page itself. So let's just run the first one. Now we should have all the list of all the URLs. It's here, 20 URLs, I suppose, and they are different only in the very last. Yeah, so they differ only by items offset value. And now let's run the final function. I will run it only for the first page because just to save our time. And yeah, here we are. Let's see what we scraped. It's not very nice to look at it here, but at least we see that we scraped some data. It's not empty, and it has some values, dirty and not clean. So basically, I already did it before, and I put it to GitHub. So here's the link. Feel free to go there and check it. I saved the listings from Marhofen in the CSV, and I should make it bigger. Make it visible. Great. So basically, it's URLs, the name of all the apartments, the headers, the rooms. And that is, for example, the thing which we'll have to process in the future, because it's a string and we have to parse it. We have to know how many bedrooms are there, how many guests, bath and beds separately. Also, we have facilities, which also stores some, not random, but are quite arbitrary information. There could be Wi-Fi, but there could be a dishwasher or free parking. So we also have to process it somehow. Then this badge, it's present only in few occasions. And we have a new lower price badge, and basically that's it probably. Also, not all accommodations have the ratings and reviews. Sometimes it's a new accommodation probably. And the price, which is also a bit dirty. You see that, first of all, we have the name price here, which we have to eliminate. And also sometimes there is a discount price for the accommodation, and in this case, we are scraping all of it. We also have to pre-process that afterwards, or post-process it. And the very last element, superhost, it's also mostly empty. Not all the hosts are superhost, which is reasonable. So that's kind of a result of what we did today. And that is scraping of search pages of Airbnb. But of course, if we go to the detail page, we have much more different information. It's more detailed. It has detailed prices. It has house rules. You can extract amenities from here. And you can extract the rating for the host from here, and even the reviews, but I hope that we won't do that. And actually, talking about these beaches, I think somewhere here, no. Well, maybe the beach is not relevant for Marhofen, but whatever. Cool, so I think that's it for the coding part, and we can jump back to our presentation and discussion.
Yeah,
and we could talk a bit about some issues. I think I tried to generalize them and put a couple of them to this list. And I think we named them already. So some obvious problems that we could meet is that Airbnb will change the class names or the whole page structure, and we have to retune our scraper again. And of course, they can block our crawler, and we have to somehow deal with that. and also A/B tests. So I'm pretty sure that Airbnb runs many A/B tests at once. So there is a chance that we somehow find ourselves in something different, in a page that we didn't expect. So it will hold different elements. It will, for example, it won't have the badges. It will have something different besides the badges instead of them. And ideally, we have to handle as much as we could. And also a bit about the next steps. So as I already said, we have to process the information from detail pages, and these pages are dynamic. So you cannot just use the requests and beautiful soup like we did before, because if you try to extract the HTML code with the requests library, you won't have any elements which you're interested in. They are loaded to the page dynamically with some JavaScript, and you have to wait for a couple of seconds for them to appear.
Damn, JavaScript again.
Hopefully. Yeah, and also, of course, the next steps for our project. So machine learning models, they need clean data. Of course, we have to clean this data and to build features out of it, and think of some techniques like filling the empty values and so on. So I think that's mostly it from my side. If you feel
right, great
to discuss.
Yeah, great. Thanks, Igor. It was a very nice, at least as an introduction, of course, very interesting. And just wondering how we going through the steps for the next meetups and how it all will grow in a time. So yeah, very curious on the project. So next steps are gonna be So in general, the format of what we work in as a together project. This is we call it XT or X technology. Is basically the format is to have a meetup at least once the other week, once to 2 weeks, let's say like that. So the next event is already planned for 13th of February, same time. And that's actually I like the most from these meetups, because we just start on Saturday, and then all the weekend is free. That's very cool. Well, of course not for those who live in Moscow, but but we don't care, right?
Sorry, Andrew.
Yeah, and that's maybe the best fit for European areas, but also fine for Moscow. So yeah, our next step is basically introduce the other project. It's called Pizza Script. I am going to be the presenter next time, and this project is about to build your interpreter for a kind of new language, new programming language. So we also will build a programming language in a set of next meetups. And we're gonna start with again introduction to the project. So I'll try to explain some basics of programming languages, what are the grammars and blah blah blah. So there's gonna be a little bit of theory, but also some code that's gonna be built in Go language, as we announced already. And the challenging part for me, not only Go language, because I'm not fully expert in that area as well. That's also an idea of our project, is to craftsmanship and learning new technologies and trying to get new theory to grasp new knowledge, basically. So yeah, we practice some Go language, and especially the library reactive X pattern. So RxGo will be used as a part of interpreter. And in the first part, I believe we're gonna build. I still hope it will work for me. So we're gonna build a simple calculator. So we're gonna start with that, but it will be already built on top of RxGo. So if you're interested in anything of that, please join us, and please join any channels that we already mentioned. I also put a small survey link into the YouTube chat. So please, if you have just 1 minute, please fill it in. Some just 3 questions in there. How was the session basically for you? Please. Right, I shut up.
Oh, so abruptly. Well, yeah. So I tried to put a teaser image here. So if you like pizza, you should definitely go there and see how Alex will run his project. It will be super fun. And well, that's basically it. So if you would like to somehow connect with us, ask some questions, or see what we're doing, what we're writing, what we're coding, here are some links.
Yeah. We're actually negotiating with Andrew right now, so maybe Andrew will also present at some event of the next sessions.
What do you think, Andrew?
Oh, I can hear you.
You're muted.
No, I'm not.
Not well. We can guess what he's talking about.
Yeah.
Probably he's telling that. Well,
he's telling, yeah, of course I will. I will present.
Yeah, yeah. Nice.
Yeah. Yeah, something is wrong with the audio, but I hope we didn't take too much of your time, and thanks for being here. Was
yeah.
Yes, of course.
Yeah. So Andrew will definitely participate. Yeah, so thanks once again, very much for joining and for watching afterwards. It is really nice of you for going here and spending time with us.
Yeah.
We will do it once again.
Okay. See you later.
Yeah. Bye-bye.